Hey, it's time for another DIY PCB-based battery project. This time, it's going to be sponsored by PCB Way. Let's get started. All right, currently there's a ton of cool commercially available battery products, right? Let me show you two of the best ones that just came out. This one right here is the Bluetti AC200P. I reviewed this on my channel. It's a very good battery box, a solar generator, power pack, however you want to call it, right? And then this one is another one, Ecoflow Max, right? And then there's a bigger brother, that's the Ecoflow Pro, which I am going to review here coming up in the next few weeks, right? These two are top of the line battery packs that are commercially available. You can buy these. This is in Kickstarter right now, but they'll start delivering pretty soon. This started on Kickstarter, but they're now being delivered. You can just order them, right? So here's the thing. There's a bunch of people that are asking, these are cool, but how can we add just a little bit more battery? Because the battery that's in there is not enough. This one has 2 kilowatt hours. This one has 2 kilowatt hours. So we've made these before. We've made some booster packs. That's what I call, right? So you put a battery outside and then you boost the battery capacity of this, right? So much that Bluetti themselves have now introduced one of their a similar product, right? So the things that we're doing, right? But they haven't come out yet. So, well, why not just buy that one, right? Well, you know, you could go that route. There's nothing wrong with you just buying that one, right? But you'll have to wait and you'll probably pay more than the DIY version, right? I want to build one that is available now and it's going to be affordable and it's going to be easy to build, right? And so I'm going to base it around this Makita box. This is a toolbox. We're gonna put batteries in here. We're gonna put a little face in here and then a little connector that's you're gonna be able to connect this one or this one and boost it up by a lot, by 3.3 kilowatt hours, right? So 150% more battery adding to either one of these units. So let's get started. All right, so first things first, we gotta choose the battery. In this case, I decided to go for this one. This is lithium iron phosphate, which means it's safe and long lasting. And this one in particular here is very affordable because our original intended purpose for this is obsolete. So they built these and then they didn't use them for the thing. So now I bought huge amounts of these. And so I'm able to offer them for a very, very reasonable price. So I already tried and I can put about 9 of these inside that box. So now we just gotta make all the connections to connect them all together. And in this case, these are 16 volts, which is pretty useless for anyone, but if you put 3 of them in series, then it'll create 48 volts, and then that's perfect for charging. Well, that's perfect for all kinds of applications. 48 volts, it's a pretty universal standard, and you can use it for all kinds of things, including charging both of these commercially available power packs, right? Here's where PCB Way comes in. All right, here we go. I'm using a free online PCB software. You can download this and use it. There's a few different versions. I just picked this one, right? So here is the size that we want to do this PCB, right? And I just measured the inside of the box, one of the sides. We're gonna put this on the side. And then here's the top layer. You start adding the top layer. And all we want to do is connect 3 of these batteries in series, right? So here's the first connector, the second connector, and the third connector. So you connect those, this pin to that pin, right? And then you connect this pin to that pin, and then this pin goes in parallel with the other one. And you can see here that I ran these traces, right, to connect everything first, and then I went and filled this out here to put as much copper as possible. This is a good thing to do because, well, the more copper it is, then the more current that it can carry. Not that this thing is gonna need to, you know, do a high currents or anything, but you know, it's just habit of doing it. I'm always trying to push the limits here. And then this right here is another circuit we'll talk about later. This is for initial charging and balancing of the batteries. Here's where we're gonna put the meter, and then here connectors, and then a fuse, right? And then you start putting those layers. That's the front, this is the back layer. You put both of them in there. They kind of mirror each other, so that way you use the front and the back. Then, of course, this is silk screen, right? Of course, here's our sponsor, and the reason is because I order all these boards from PCBWay. They are affordable and they do them really quick. Like within a couple of days, they usually get them done and then they send them to me. And so there we go. Here is the name of the battery, and then here's a URL link where you're gonna find this video and all the instructions on how to run this, right? So there we go. There's the bottom layer, all the other ones. Here's a 3D render of the board. This is what it's going to look like, right? And of course, this is sort of the shunt, so that we can do the meter right here, and everything else is labeled. So there you go. This is the front, this is the back, and then now we just go to PCBWay and order this, right? So we have to make a Gerber file, which I am gonna make available for anyone that wants to do this, and then order it there, and then it'll come in the mail. The next board is gonna be the face cover, right? We wanna put these components in the box, but you know, these are hard to cut by, to measure all this stuff. So I thought, oh, just make a board and we'll put all the components in there. Then we can interconnect them, and then we just worry about making a large hole that's within this sizes, right? And then that's going to be much easier, and we have to only worry about one hole. And so then those are the two. There's another board that goes in here that is to make the XT90 connector, right? And then you'll see that. All right, so it's been a few days, and of course PCBWay sends the boards, and here we are. I got ahead of myself and I started populating everything, right? So here are the little connectors. These are the connectors that those batteries use, and then you just populate them by putting them in the little holes here, making sure that you follow the little pin right there, right, that's connected there, and then you solder them on the other side. There's not a lot of components here. It's basically 9 connectors, and then one fuse holder, one charging cable, right? All this stuff is going to be linked in the video here, and then an XT90 connector. Here, you just screw those on basically, and then put one little jumper from that connector to this thing, and then you use all these bolts come with the meter, right? And then there's one little connector here for this section. Now here's the thing with this section. In the rush for me to design this, I made a mistake, right? These connectors go in here. And the problem is that they're too close together. And so if we populate all these right here, then you'll be able to connect those in here, but then you won't be able to get them off easily. And so the fix for it is to only use half of them, right? So if we only populate half of these, then you get the space in between that you would need to be able to do. Now, what is this section for? As the PCB here states, this section is for initial balancing charge using an 18-volt, 2-amp power supply. It may take up to 72 hours to complete. What this means is that when you get those battery packs, those have been sitting on that pallet for a long time, and so some might be completely dead, like 0 state of charge, but some might be like at 30% state of charge, and some might be at 80% charge, right? And so I have no way to control that other than just charge every single pack, and it's just better to let you guys do that, right? Because I don't have the time. I would have to charge you for that, so that it will increase the price of these batteries, right? So I made this here, and all you have to do is populate it and then connect this power supply. It's an 18-volt, 2-amp power supply, and then you connect all your batteries in here. Of course, you can't connect all your batteries because you have 9, and we'll only be able to do 5 of these, right? So you'll have to do them in 2 sections. You connect 5 packs in here, connect it, leave it there for up to 72 hours. And then at that point, all of them should be charged to the very top, to 18 volts, and they should be okay. And then you take the other 4, connect them here, then you run that, and then you let them charge all the way up till they're 18 volts. At that point, all of the packs will be at 18 volts, so 100% fully, charged. And then we'll be able to connect them in here, and then you won't have mismatch or imbalance problems, right? So that's what this is here. I haven't solder this in here, so let's solder those now. All right, next we'll take a look at the small PCB. This is pretty straightforward. The battery meter, you have to do is just screw it onto the hole there, right? And then on this side is the same thing. You have to get this thing, and then it just screws on there, the screws. Then you will have to, this just comes with cables, so you will have to cut an extension cord that has this end right here, and then solder it this way. Black with the red, the white with the purple or blue, and then the green with the yellow, right? And then you do it like that, and then you only need like about a foot of distance, and then that's it. And then the section in the center, well, that's interesting. These are surface mount stands or terminals, right? So that's so that they don't come out in the front. And you solder them on the surface, and then you put these little standoffs. And then here is a third board that we're gonna use, and this is an XT90. Now this is the prototype, but the final version is gonna look a lot better. It was really big on mine, so I just had to cut it with scissors and stuff just to make it fit in here. I guess I could put the final version. I do have it, but I don't have it here. It's in another warehouse. So this one will have to do for this video. So then all you have to do is just put it in there. The screws, tighten those screws. And this is what it's gonna look in the front. See that? Okay, that's it. Okay, now let's talk about the balancing procedure, okay? That's this section right here. When you get your batteries for the first time, they're all gonna be at different state of charges, right? Most likely. And even if they're not, this procedure here will just charge them up, and then it won't harm them in any way if they are already balanced. But I doubt very much they're gonna be balanced. So what you do is you connect 5 packs in here. Next one, take that thing, one in here, plug it in. All right, so now you have 5 packs connected in there. Then this right here is the 18 volt, 2 amp power supply. What you do is you connect this guy up here in the little connector, and then you connect that to the power, right? And then you have to leave this a long time, 72 hours. That's my calculations, how long it's gonna take for these to be charged all the way up if a lot of them are completely dead, right? And then you do that with the other 4, right? Because there's 9 of these packs that you'll need for this process, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And you do that. And then once they are all in here for at least 72 hours, then they should all be charged. And then now we can put this and the face into the box. So let's do that now. Okay, so here are the tools that you're gonna need. You're gonna need a drill, and then a drill bit, some kind of marking thing, and then a cutting tool. In my case, I'm gonna use this jigsaw, right? And that's gonna be to cut the front face. So this guy is gonna go right here. It fits in here, you see that? Yeah, okay, let's mark those holes. Okay, so what I've done is I mark those holes in there in the plastic. And so we're gonna cut right up against those holes here, right? Same thing here, right along the edge of those letters. And then we just gotta make sure not to cut right where those holes are at, because that's where the screws that fasten this head, this face is gonna be at. So there we go. Now we drill holes along this edge here so that we can start our cutting machine. Drill the holes. There we go. You gotta make kind of long holes there. And I made the first mistake. I already cut through that hole. Now it's a bit messy here. Okay, so I'm just gonna use a knife to deburr the edges here. That's just to get rid of the extra stuff. Now let's see if it see if it fits. Okay, so we might have to take this one off. There we go, look at that. It's pretty good. I think there's a couple of little issues here. Here, and then here. Okay, so I think there it is. Look, it's hard to make perfect holes, and that's the reason why this exists. It's so that you can make a rough hole like this, right? And then we can cover it up with this nice PCB there. All we have to do now is just screw it on. There we go. I will screw this guy back in there. Okay, now that we've cleaned out all the debris from that stuff out of the box, now the next step is to put the whiteboard in there. And you can use these standoffs to secure it to the edge there. All right, so I just drilled some holes and installed the screws. On this one right here, I had to drill a bigger hole on this side, and then a smaller one on here so that it could go in there. You see that? So it goes only to this layer, not through that. You could also just get a longer bolt, but I didn't have one, so I put 3 bolts in here. That's good enough to hold that in there. You don't need a 4th one underneath. If you want to, you could do it, but I didn't do it. So there we go. Now the next step is to put all the batteries in here and then start connecting them. All right, first battery goes in. And we're not gonna secure these ones. They're kind of tight, so they don't move around once you put all of them in there, right? So you connect that first one there, second one, and then that will be that one right there. Third one. Oh, actually no, wrong. You don't connect any of them up here. So what you have to do is connect them only on the 9 that are inside. There we go. See, we almost made a mistake there. If you do that, it won't work. There it goes. Then third one up here. Yeah. It might be hard. We might have to do this one first, and then this one last. If you do this step and you don't have enough plugs, or you have extra batteries, or then that means you skip one, right? And it's easy to do. I almost did it, right? And so you just have to go take them all off and then find out which plug of the center cluster of plugs is missing a battery, and then you have to reconnect it. Okay, so after that, you should be able to connect this guy. This is this cable that comes from the meter right here, and we plug that guy in here. We should be able to get, yeah, look at that. We already have 49 volts. These packs are fully charged. Now let's connect the main power. This one right here goes onto this one. And now that's the plug in here. This should be live now. So the last thing that we have to do, you route this over here, is connect the charger. Charger that I recommend for this project is 54.6 volts, 4 amps, right? And this one already comes with the power pole connector. So just make sure that when you plug it in, they match black to black, red to red, because sometimes these, they put them, you can put this differently, right? And if that's the case, you can take this apart, one off the other one. You see that? You can put them this way, you can put one in the left, and then the black on the right, and then you can do it the other way around, one on top of each other. So you can change the configuration on this guy. So just make sure that it matches, and then you connect that in here, and that's your charger. And then the last thing is gonna be this cable. It's going to go in here. There we go. And there it is. The charger's light come on. That's just that it is, the battery is connected. When you connect this to the power, and turn it on, then the green light will turn on here and it'll start charging your battery. There we go. So now that is your battery. Okay, the last step is going to be to set up the meter. So we know this is a 3.3 kilowatt hour battery pack, right? Because it's 370 watt hours per module, and it's got 9, right? So if you divide 3.3 by 48, it equals just under, it's like 69.7 or something like that. So it's almost like 70 amp hours, right? So what we have to do is we have to click on here. Just help me here. Okay, there we go. So then you click on this arrow here until this starts doing that, right? Capacity. So this is where we're gonna change now. So you click on the thing, now we're there. So 70 amp hours. Amp hours. And then I guess you hold it. Oh yeah, you hold it a bit, and then the arrow starts moving. Right now, full voltage is 54.6, so we have to adjust that. Now 54. Oh, I guess 54.6. And then 0 voltage is about 38 volts. So there we go. So then you just hold this. Now, to get out of this, what, you just hold it down. Let's see if that does it. Let's hold it up. There we go. So it estimates that it's at 50% right now because of the 49.7 volts, right? So full is at 54. So then we have to charge this to get it up to 100%. Okay, so here we go. I plugged in the charger, right? The charger's inside. All you have to do is plug in a regular cord, like a computer plug or cord, right? And then when you put it in here and you turn the switch, then the meter starts recognizing that you're charging. Oh, look at that. Why did it put it at 0? That's weird. So there we go. Starts counting 9 milliamp hours into the thing. It's 1.9 amps, which is weird because this is a 4 amp charger. I guess it's gonna ramp up, or maybe it's ramping down because it's already at 50 volts. I think that might be the thing, right? So you let it charge all the way up, and then once that happens, you use the up and down arrows. You just hold it until it says resets to 100, and then that's it. Now your meter is sync with your batteries. When you have batteries, now you know that they're 100% state of charge, then your meter reflects that, right? And as you use it and discharge it and charge it, then that's gonna go up and down. Okay, now let's talk about how you use it. The Bluetti comes with this solar cable, right? And so all you have to do is plug it in here, and then the Bluetti is gonna wake up and it's gonna start charging at 500 watts. It will charge this 1.5 times. This has got 150% more battery than the Bluetti. And so when this one's completely dead, you just plug it in here, this one will charge it. It'll charge it slow at 500 watts, right? But it'll charge it all the way till it's full. And then you can discharge it again, and it'll plug it in there, and then you can charge it up to about 50%, 150%. So that's the Bluetti. What about the new Ecoflow. All right, so the Ecoflow doesn't come with a cable that's very usable for this, but all you have to do is make something like this, right? This is a male XT90, right? It goes on here, and it's a female XT60, right? And you could either make this or you can buy it on Amazon. There's a bunch of adapters that you can adapt to go in here, right? And so it's the same thing. You plug it in, charger. There we go, and it turned on. This would get charged 150%, right? So 1.5 times when you have that as a booster pack. And so you can keep using your device here. All right, so I know the next question that is gonna come is, can I use this with my other device? And the answer is yes, very possibly. If your device can accept around 50, disconnect this, about 50 volts, right? Down 38 to 50 volts in the solar input, then you can connect this guy, this battery into it, and then that way you'll be able to charge it like that. Also, the other thing is, can I use this battery for something else that is just 48 volts? And the answer to that is also yes. Now this thing is loud. The answer to that is yes, you could use this battery to power anything else that is 48 volts. Now here's the catch. It would only put out about 15 amps. After that, the BMSs on the packs will shut down. Those packs are more for energy storage, more so than power delivery, right? And so that's why they're kind of wimpy. But if your device that you want to plug in here, it's less than 15 amps and requires that, then you can plug in here and it'll be good for 3.3 kilowatt hours. Okay, let's talk about pricing. Look, this is a DIY project, right? And there are levels of DIY. And now I'm gonna give you all the links so you can buy all the separate parts and you can build this, right? If you do most of the work, then you're gonna pay less, about $500, I think, right? About $500 for the total project. Now, if I make the PCBs and solder them for you and do all the stuff and I ship them to you, because I'm gonna also offer it that way, then you get to do less of the work, but you get to pay a little bit more, about $100 more, about $600. So that's $600 for a 3.3 kilowatt hour battery pack. And by the way, that's including everything, the box and the charger, all these other things that you will have to buy from somewhere else, from Amazon and AliExpress and stuff, right? That breaks down to about $187 a kilowatt hour. Is that expensive? I don't think so. Bluetti's releasing their own batteries and they haven't released the pricing yet, but I can assure you that they're not gonna sell it for about $400 for a 2 kilowatt hour battery, right? I think it's gonna be somewhere around 800, and so it's gonna be somewhere around like $300, $400, $500 a kilowatt hour. Famously, the Tesla Powerwall, it's about $500 a kilowatt hour, right? And so this pack that you build yourself, and you can get it for about $185, $187 a kilowatt hour. Well, that's a very good deal, right? For lithium iron phosphate batteries that is safe and long lasting, right? And it's compatible with your thing. So there you go. You can get it. You can do most of the work yourself and pay less, or you can let us do some of the work for you and then pay a little bit more. Also, here's another thing though. Developing these products, it's really hard work and it takes a long time and it takes a lot of labor. And so we only made like 30 of these kits so that you can put in. So once those are done, that's it, those are done. Now the only way, after those are sold out, the only way for you to make this is going to be by buying all the parts yourself, ordering the PCBs, and then soldering them yourself, getting the batteries. And so you're gonna have to do most of the work, right? So it's a limited amount of kits that I'm gonna sell for this one. And then after the batteries sell out, then that's it, right? Nobody's gonna make these, because then we're gonna move on to another battery type, and then we're gonna make products for that stuff. But for right now, this is available. It's about the easiest battery to make. I just built it in like half hour, and that's because I was explaining everything and I'm talking to the camera, right? But you should be able to do this easy, right? So there you go. Thank you to PCBWay for sponsoring this video. If you want to get all the parts and order the PCBs, I'll have a link in the description. And then if you want to just buy some of the parts the kit that I'm making, it's also going to be in the description. All the parts links are going to be in the description. It's amazing how many people ask me where to buy the things when my descriptions are full of all the links of all the products that I talk about in the videos, right? So don't ask me where to buy the stuff. The links are in the description. Thank you for watching this video. We'll see you guys on the next one with another project, another DIY project. There's a bunch of them coming up, so stay tuned. If you like building stuff, you're in the right channel. All right, thank you. We'll see you. Bye.